Welcome to 4.19. This is the last lesson of the unit, and so we're going to define a couple things that you probably haven't heard of yet, but aren't very complicated, and you'll understand what they mean in a second. So they're cosecant, secant, and cotangent, but don't worry about that right now. We'll get to that in a second. So to begin with, let's go ahead and take a look at a couple of things using the Pythagorean identity from today's class. So we want to show that this equation is equal, and to do that, we've got to make both sides the same. So pick one of the sides. Remember we talked about this. Pick one of the sides that you think you can work with most easily, and see if you can manipulate it so that you get it to look like the other side. You can pick either one. So go ahead and give this a try on your own. I'll go over it a little bit in detail, and then you'll do this one totally on your own. Okay? So I hope that went well enough. What I would do is I would pick this side to work with, and the reason is that over here, and you can do this either way, you can pick either side and you'll be able to figure it out. But the reason is that over here I see that I have sine squared of theta as the only denominator in my only expression. And when I look on this side, I notice that I have a sine squared theta as a denominator, but I just have a 1. And so if I can just find a way to combine these two and remain with sine squared theta, I should be able to get what I'm looking for. So I'll go ahead and add these together, and 1 is just sine squared theta over sine squared theta plus cosine squared theta over sine squared theta. Right? And this would just be, how would I add these two together? Let me give you an analogous example. Imagine you were adding 1 plus, you were doing 1 plus 3/5. Well, you would rewrite 1 as 5 over 5, and when you add those together, then you'll get 8/5. So I'm just looking for that common denominator, which happens to be sine squared theta, and then when I add these together, I'll have sine squared theta plus cosine squared theta over my common denominator of sine squared theta. Well, what is sine squared theta plus cosine squared theta? By the Pythagorean identity, that should be equal, is always equal to 1. So this expression here is simply 1 over sine squared theta. So what I would do is I would say, I would write out my solution. I would say I'm going to manipulate the left side of my equation, and I would go through these steps, and I'd say, so we see that the left side of my equation is 1 over sine squared theta, which is, of course, the right side of the equation. So therefore, these two sides must be equivalent. There's one last thing that I do want to talk about, and that is there ever a situation where the left side and the right side won't be equal? So pause the video and just think about different possibilities. What would make a fraction kind of tricky to deal with? And you probably think, okay, well, remember, fractions with a 0 in the denominator are often not very fun. And so you'll know that, well, sine of what is 0? Sine of 0 is 0, right? So sine squared of 0, if I haven't turned any number of radians, is going to be equal to 0. And so then I would have 1 over 0. So it's important to note that while this equation works for most values, there are some that will give it trouble, because now the right side of my equation is undefined, right? This would be undefined, and in fact this would be undefined as well, because I would have sine squared in the denominator here. And something that's undefined is not equal to something else that's undefined. So we have to be careful with these values. All right, so now knowing that, I want you to go ahead and tackle this one on your own. And this one can be tricky, so don't get too frustrated if you're struggling a little bit. At the very least, you can sort of think about whether there are any values for theta that will cause this equation problems. So before you go ahead and press play again, at least think about this situation here and see if you can figure out which values of theta would make this equation tricky to figure out. All right, hopefully you made some headway there and at least thought about the values of theta that would make this tough to evaluate. So I'll talk about that quickly. We have 1 minus cosine theta in the denominator. So if cosine theta were ever equal to 1, we'd have an undefined value here. Well, cosine theta is equal to 1 when theta is 0, right? So if my rotation of my radian value is 0, then cosine of 0 is 1, and I have 1 minus 1. So that would be a particularly difficult point where I would not be able to say this equation is true. As far as being able to actually make the left side of my equation equivalent to the right side, I'm going to manipulate this a few times, and what I'll notice is that sine squared theta is equivalent to 1 minus cosine squared theta. And at this point, you now have this in your numerator and this in your denominator, and you're thinking, well, this is what I eventually want it to look like. And what you want to notice here is that this is actually a quadratic term, right? It's to the second power. So you can write it as its 2 linear factors, each with a cosine theta. Each with a cosine theta. And that will help you get to where you're trying to go. So hopefully you'll be able to finish that out. Make sure that you have that in your notes so we can discuss tomorrow. And now let's move on to the new stuff. Okay, so here's the situation that we've kind of been dealing with all unit. Right, we have our unit circle here. We've defined cosine to be the x value of any point on the unit circle. Sine is the y value of any point on the unit circle. The argument for each is the number of radians that I've turned, right? Where am I on the unit circle here as I move around? And we've defined tangent to be the sine over the cosine. In other words, the slope of the line that passes through that point. And there are actually 3 more trig functions that we want to talk about: cosecant, secant, and cotangent. And these are not tricky at all, to be perfectly honest. They are related to sine and cosine, just like tangent is. So cosecant, secant, and cotangent are known as reciprocals. They're the reciprocal of sine, cosine, and tangent. So cosecant is the reciprocal of sine. And so what that means, reciprocal, right, means my numerator and my denominator switch their roles there. It's not too hard to remember. And so cosecant is just going to be 1 over the sine of theta. Secant is going to be the reciprocal of cosine, so it'll be 1 over the cosine of theta. And cotangent is the reciprocal of tangent, so it's going to be, instead of sine over cosine, it's going to be cosine of theta over sine of theta. All right. And so what I want you to do is I want you to give this a little practice. So I want you to imagine that this angle theta here, set this up so that this angle theta would be 3 pi over 4. Imagine this were 3 pi over 4. Right, so it's rotated 3 pi over 4 radians out to this point. Find the cosine, the sine, the tangent, cosecant, secant, and cotangent, just to make sure that you're comfortable with that. And then we'll go ahead and actually find some of these values in a real question. Okay, so here's one for us to try. Sine of theta is 5 over 13, and theta is less than pi but greater than pi over 2. And you want to find cosine, tangent, cosecant, secant, and cotangent, and then estimate the value of theta. So if you are struggling to remember how to do this, you can go back and take a look at the previous video or look in your notes. But the one key tip that I'll give you is to remember the Pythagorean identity. And then, of course, for estimating the value of theta, I want you to try and get more precise than this here. So try and give a more precise value of theta. And what I would like you to do is, in your comment, I would like you to post I would like you to post the value of secant of theta. Okay, so that's the one that you want to make sure is posted in your comment, and I will see you guys tomorrow.